I have a 600i behind me. Those that haven't seen it, this is what it looks like. It's on right now. That was the back you're looking at, and that's the front. You can see the carrying case is right on the top of the bookshelf. Quite compact. Quite compact. If you have not seen the 600i before, the new RIEGL 600i. It was introduced late 22. Then last year was our first full production, but now our second full production year, deliverable times has decreased quite a bit too as well. So, okay, I'm going to go ahead and start. Okay, welcome everybody. My name is Nguyen. I am the division manager for RIEGL USA. We're located in Winter Garden, Florida. Beautiful Florida. Winter Garden, Florida is quite nice outside this time of the year, and ready for the beach weather. Okay. All right, let's get going. And we'll save the questions for last. Take a quick look at the agenda. Quick overview of the 600i. I think those of you that know the 600i seen its performance, but those that are new can definitely get a quick overview for it right today. Some new software stuff. So since the 600i has been on the market, we introducing new software suites, new tools, new modules, new plugins, and some of these software suites is also over to our kinematic side too as well. And this new software suite is called RIEGL Deep Learning Suites. It's part of an AI program that we implemented for our software for auto detection, black and white targets. Also, more features to come with the AI software suites in the future. So this is a new attempt for us, and a first attempt so far. I show you what I've found and what is useful, the new RIEGL Deep Learning Suites. And then last, I have a project that I've been working on just for this particular webinar. Nothing too elaborate, but this project will that I will show will answer all your questions. I think those that have seen my title and those that are logged in probably want to stick around to the last part. The TLS to MLS, not much wording, but you'll see it at the end if you stick around. Okay. Let's go ahead and get started with the 600i. So as you know, the 400i has been on the market for quite some time. That has been our go-to scanner for most applications, and outdoors, indoors, and whatnot. And then we have our long-range scanner, more so for the mining application, slip stability, monitoring, research. This thing's incredible. It shoots out to 2,500 meters, 2.5 clicks, quite nice. And it also shoots short range too as well. So it's not just a long range scanner, right? So all these things, when I say long range, of course they shoot short range. And then of course the new 600i. This is an incredible system for us. About 2.5 years in release, in production, and it's here to stay. I've been with RIEGL for going on 17 years now, and I've seen the full suites of RIEGL terrestrial laser systems from the first Z series all the way down to the 600i. I can tell you, our technology keeps on improving. It's faster, it's more productive. Now it's smaller, right? So it's meeting the demand market for laser scanning, traditional tripod, especially now these days when these scanners are so fast. You got to be able to move around, right? So you got to be able to carry it. It's got to be flexible. It's got to be easy to use, and it's got to be user friendly. Okay, and that's what you get with a 600i for sure. Moving on, just look at some performance. I just want to get some highlights. One of the unique things I love about our systems is that it has selectable pulse repetition rate. What that means is that depending on your applications, you can select the pulse rate to dictate the range, right? It's only simply because we use a time of flight technology, so that we simply just have to slow down the mirror for that pulse at longer range for the timer the encoder to receiver and to log it properly, right? So we got an incoming pulse, and the incoming pulse, we can calculate the distance by the timing received from the incoming pulse, right? And also, unique thing about this is also is the max number of targets per laser pulse. Yeah, this may not mean nothing to some, may means a lot to others, but this is great for vegetation, penetrating vegetation, and also forestry. Yeah. So just example, when this laser shoots out, it's a single pulse laser. It just fires one at a time, but the receiver can decode multiple returns. So what that means is that when you shoot into vegetation, you're not only getting, for example, from the high up shooting down, you're getting the canopy, you're getting the middle of the canopy, and also more importantly, you're getting the ground. So you can remove the ground, classify the ground, and give you a digital terrain model, which is a typical DTM. So you got to be able to remove the vegetation, but more importantly, you got to be able to capture the ground with using multiple targets return systems. You know, up to 31 returns on 100 kilohertz. You know, it's because our onboard computer processes everything in near real time. Going back down, our laser precision and accuracy is very standard across the board, but we have introduced something called the high precision mode. You know, the high precision mode will then reduce the precision to less than 1 millimeter, which is incredible. Now, we don't recommend to scan this all the time, but if you're ever doing something that requires high precision within a certain range, you can certainly use this feature. So what you do is that you just take a quick 360 scan, and then from the big screen onboard interface or from your phone or an iPad, you can then arrow and select your area of interest, and then enable the high precision mode, and the area that you're scanning has very high precision. So something good that I see this going on, for example, substations, right? So when you need to look and scan very high detail and high precisions of certain conduits or electrical circuit or cables that are smaller, or you know, anything that needs high precision, or also for architecture too as well. So you need to scan a very detailed facade of a building, of interior, exterior doesn't matter, and also floor flatness too as well, right? So if you're building these big Amazon warehouses, particularly now more than so ever, they require very high precision of floor flatness. It's because these big warehouses are putting machine controls, right? So automated extractions of goods. So you got robots running through this level floor, so it needs to be level as much as possible. Yeah. So some very interesting feature, and also some new features, but also scanning it up to 1,000 meters. Absolutely incredible. And half a meter for short range, right? Let's continue to look at some performance specs on the 600i. So I've tried to emphasize this as much as possible in the last 5 years. I thought the buzzword is productivity. I think laser scanning, that what I've seen has been challenged. Yeah, it's been on the market for quite some time. I think it's at almost getting into a mature level. These lasers or systems are very accurate across the board, precise across the board. So I've seen the challenges. I've seen people lobbying to use this technology. I've seen people give feedback and kickback and pushback. Now it's adaptation stage, I think. I think now when you look at the system, you have to look at productivity. And productivity does not just stop out in the field. It ends in the classroom or in an office with a deliverable point cloud, whether it's to a client or for internal use, such as for design or for inspections or QA/QC. Doesn't matter. It ends at a deliverable product, which is a perfectly calibrated, registered, homogenized, georeferenced point cloud. That's productivity. Now, of course, it starts out in the field, but it ends in the classroom. So, counting on going off of that, so you look at the scan time, yeah, 30 seconds, less than 30 seconds. In fact, it's 25 seconds for a 6mm resolution point spacing, right? It doesn't stop there. It also acquires images at the same time, simultaneously. So as it's scanning within that 25 seconds, the images and the cameras are also firing too as well. And there's a couple of camera options. I've already covered that in my last webinar. But if you want to know, we have the 600i does have 3 internal 12 megapixel internal camera, but also optional external camera such as a Sony, a 360 camera. Yeah, and those are the 2 other options. So if you want to know about it, contact us and we'll give you more information. So we try to quantify our production. Now, of course, here 60 scan positions per an hour. So if you do the math, 30 scans a second gives you time to move. But in my last webinar, I highlighted the production and performance based on real-world testing. Now, based on real-world testing, a whole summer of scanning for indoor, outdoor, transportation, BIM, all these projects that I do have survey control. So because people say, hey, you know, you never account for survey control because you got to stop and just scan them. I do. And actually, I'm getting 1 minute and 20 seconds per scan position. So still very good, still very productive. You can count on the system to quickly, you can really move with the system. So yeah, let's continue. Although the system does look quite different, those that knows RIEGL have known RIEGL to be very robust, aluminum housing, good structure and backbone to the scanner. And when you look at the 600i, you know, we had to reduce the weight somehow. So we changed a little bit of materials used. We changed the shape and dimensions of the scanner. But nevertheless, we still kept the integrity of the scanner, making it still IP64, which is dust-proof and splash-proof, and a high broad temperature operation ranges, right? So it operates in -40 degrees to plus 40 degrees without any problems. Like I said, although it looks different, the form factor is different, the material may look different, it's different on the outside, but still maintain a very robust system. You know? But more importantly, we have reduced the weight, and that's one of our biggest achievements, I think, in my opinion, for the 600i. Of course, it's jam-packed with cool technology as well, and we'll see that in a little bit. And this should be the last slide on the on this 600i. And if you want to know more, of course, you know where to contact us. If you're in a different part of the world, contact your distributor or nearest reseller. Couple of things new to the terrestrial world, terrestrial segment, terrestrial scanners. The last RIEGL development of all terrestrial scanner is the integrated cameras. I did not think that was gonna, I didn't see that on the horizon. I just thought, hey, it's gonna be a smaller scanner and it's gonna be brilliant, which it already is. But having the internal camera also reduces weight too as well, because now we don't have to have a mount to it. It also reduces the amount of hardware you have to carry to a project, hardware you have to carry when you fly with it or travel with it, and then also ultimately weight too as well, right? So it's lighter to integrate little image sensors versus imaging a whole camera system. Yeah. So internally, there's 3 megapixel, which covers. Another thing that we did increase is the vertical view, just about 5 degrees up top. So may not sound much from 100 to 100. 15 degrees. I apologize. To 15 degrees, it was 100. Now it's 115. It's night and day difference, especially when you're scanning indoor and small type mechanical room. In fact, since this thing it has a tilt compensator leveling system, you can actually tilt this thing and cheat a little bit on the compact tripod that it comes with. Yeah, so you can just tilt it back up to 15 degrees or 20 degrees, and you'll get the top of the ceiling if that's your concern. But when you scan anywhere, you never scan from one position, right? Especially when you're scanning indoor in a tight room, such as a mechanical room, line of sight. There's no way you're going to scan one or two. In fact, in a mechanical room, I can see you scanning a dozen scan positions more. And if you do move it, most likely, guaranteed, you're going to cover the overhead, and that's your concern. So it shouldn't be. Right. And also the touchscreen on it too as well has increased too as well. I love the fact that it kept the same interface, right? Because if you've seen a RIEGL interface, you can recognize it immediately. It looks like your phone. It has all these apps, and the app says exactly what it does. So for example, systems, settings, new project. Yeah, you just click on it and you go. And we kept that same design. Just gave you a much bigger 7-inch display touchscreen. Yep. So very nice for our customers, especially in bright light conditions. So when you're out there working outside, you get the sun beating on you. This screen does a very good job. You can also control the brightness to it, but you can also connect it to your phone too as well, or an iPad. And let me make that clear. When you connect to it, it's a mirror, okay? It doesn't transfer data to the device. It's just a complete mirror. So when you operate it, you can control it from your hand instead of touching the scanner. It's because we anticipate the scanner to be put on a moving platform, like on top of a vehicle or an ATV or a golf cart or even a boat. Yeah. So when it's up there on top, we want to touch it with our screen so that we don't move it. Yeah. Okay. Now, getting away from the hardware, let's take a look at our deep learning suite. Yeah. So the RIEGL Deep Learning Suite is a software suite for AI-driven point cloud and image processing. So we've listened to our customers in the past. Our tools were very limited. So by introducing this AI suite, it allows us to open up doors. Yeah. So not only we're processing, registering, and filtering out the point cloud to make it look very nice, we can also now extract information from it using this AI-driven software suite. So this is the first attempt. This is new for us. I can certain that we're all introducing new tools, new way of doing things, workflow, target extraction, which we're very excited about, which I'm talking about today. That's really my main topic, is the target, right? That's the only thing that I really want to emphasize on today. And it's not part of the RIEGL RIScan, so it is a license base, right? So it is a one-time purchase. Well, sorry, there could be maintenance on it. Please contact your reseller or distributor for exact information. But it is a separate install. You can install it, but it does require a license base. Okay, you can download it from our members area. Right now, the plugins, sorry, the tools is very limited. But of course, we're expanding on that. And within RIScan Pro, you have your traction of black and white targets, which we'll see here shortly. And then also the images of face blurring, right? So anonymous face blurring. So when you're capturing the data, if you forget to initialize it on the scanner, you can then blur out the image, blur out the faces on the images in the software. Okay. So let me slow down and let me say that again. When you're collecting data, the scanner has that option automatically. The scanner could do it on board. But if you forget to enable that option on the scanner, you can bring it into our software, and then with this AI-driven deep learning suite, you can then blur out the faces and unblur them, blur them, and unblur them, blur them, and unblur them. That's with the licensing versus with the scanner, okay? So with the scanner, once it's done, it's done. It's blurred out. You can't unblur it, all right? Okay, if you have a question, I'm not clear, ask me at the end, I'll go one more time. Okay, so what are these targets? Yeah. In fact, if you are using the latest version of RIScan Pro 2.19.1, you already have it. In fact, you can print it out right now. If you go to your C drive, RIEGL LMS, RIScan Pro, help, black and white targets, you'll have 2 PDF in there. You can then print it out and then use it. Now, my testing has been limited to just paper. So I've simply printed on paper, and I've used it that way. And I'll show you how I use it here shortly. And then you can print them in different sizes. So the size I'm using is a 16 centimeter square. Okay, so you just measure, and then you take that value, and then you make a new target, which I'll show you how inside the software RiDScan Pro. All right. So again, you can go ahead and find this target inside your computer already if you have the version 2.19.1 installed, and then you can print them out yourself. Trick question. So which one is the black and which one is the white? The black is on the left, and the white's on the right. The white's on the right. Okay, you can see the black is that pizza, and then on the right-hand side, it's considered a white target. The pizza is white, or the triangle. Okay. Yeah. So here is our office. You can see this is the PDF printout. This is just normal paper. Again, this is still in my testing phase, but I've got very good results. So it's surprisingly good result. That's why I want to share it with everybody, so you can make use of it too as well. So I just print this thing, and I also have it on laminated too as well. But this, what you see here, is just black and white on regular printing paper. And now you can put this on back of a board. So our officer we have controls set around the office with just a nail and a dimple, and I just simply put the center right over the dimple and tape it, and put a scanner next to it and scan it. This thing can go on the as advertised. It goes preferably on the wall, right? So you get good angle of incidence versus on the ground. Of course, I wanted to push it to the limit, so I want to put it on the ground because I wanted to see, right? I want to challenge it a little bit. But of course, it works on walls, but more importantly, it also works on the ground too as well. So I don't recommend this, right? Because these targets, they get wet, they get ruined. So be creative. You can make the targets and put on something that is more sustainable, perhaps. But to make use of it, right? So this is a couple of things you got to do, and this is really all in the manual too as well. So you want to first, because of the different materials you're going to use and customer uses, right? So we're not limited to just paper. We can put it on, different type of material. You can even paint it too if you wanted to. Yeah. So that's why when the laser hits it, right, in order for us to detect it, not only we have to have a certain amount of points and line on the scanner, we also want to detect it using reflectance attributes. Okay. Now, if you know about our reflectance attributes, it's not angular dependent, right? It is, but only at a small, shallow angle that it's not uniform. But when we do calculate the reflectance of the black and white, the difference between the two, to have the best results, the differences between the two black and white surfaces needs to be greater than 3 decibel dB. And I'll show you how to do that shortly. It's not hard. You just do it, and then you can define your target. You can see here on the left-hand side, you just isolate your target, or you zoom into your target in a 3D view. You then just go into the selection tool. You select your triangle on the black target first, and then you click on the information, and then you get a value of the mean of reflectance. So that's negative 6.8. You can round. It's display in 6 digits after the decimal, so you can just round up to 2 decimal, which is fine. And then on the right-hand side, you can see the white, and then now you just select just the white only, and then look at the values. So you take those 2 values, you subtract the black from the white, and if it's greater than 3 dB, you should be able to use it, or the AI should be able to detect it automatically. Now you can also play around with the numbers too as well if you don't find it. I had to do that, but nevertheless, it was able to find all that. Okay, from the scanner itself, of course, to see if it's usable, it has to be in the point cloud, because if you put the scanner too close to the target on the ground, now I don't just recommend ground, right? So if you have a project I would put on some flat vertical surfaces and shoot it in with a total station or something. But I don't have the luxury, so I use all ground. Yeah, you can see here the target, the scanner's put next to the ground. And when I scanned it, there's a 2D view. I can visualize it. I can see that's my target's in there. If it's in the 2D view on the scanner, it certainly is in the 3D point cloud when you're bringing in the RISE-SCAN Pro, so that RISE-SCAN Pro can automate detect it. Yeah, you can see here the target is just perfectly fine. Now, once you verify, right? So, and then adding new reflectors, right? So you calculated the differences between the black and the white. The value is greater than 3 decibel, and you want to remember these values, yeah. So 6.8, and then also 1.2. So open up your software, right? You're inside your project, all your data's in there. You right-click on reflector, and you say new reflector model, reflector type. You then select your reflector. You select your reflector type, and then you put in your width, which is the width of the target you're using. I highly recommend, well, you should do it all the same size, right? You can do a 30 centimeter, 15, 16, but make sure they're all the same size. You don't have to, it's just more convenient that way. So you can do a batch detection of all throughout the entire project, right? So you have 100 scan position, and there's 50 in there, and if you forget which 50 has the target, yeah, so you want to do a search through the whole thing. Because if you have different targets, then you can't do that, right? Because it won't find it, because you have other target that's maybe only 10 centimeter or 45 centimeters. So it's like what you're saying. So the last two value is the min and max. That's where you put that value. When I say that value, this value right here. So the min is for the black is the -6. So you put the -6 at the minimum, and for the maximum you put -1. So I didn't want to recreate this, so I kind of just did a screenshot. I know those values are not correct as what you see here for this project. But I just rounded it up. So it was very close to -10 and -2. So I rounded it up, and yeah, so I created a target type. That's it. Okay. Now, and then you just click on this little wand to populate the name, right? So you can see this wand in a couple different places. So if you're familiar with software, you also see this little automatic or recommended naming also in our Division Manager too as well. So use it always. Okay, so there's a couple ways to extract the targets automatically. This project I'm about to show you right here, I'm working on presenting, is a project of our office. I just took the scanner outside and scanned it at 7 position, and not all the position has control, which are my targets, right? Some do, some don't. So here we go. And then you open up Division Manager. You open up multi-station adjustment 2, MSA 2, and you just go to the same workflow, right? So you, instead of step 1, generate the targets. So before you generate them, you want to make sure you click on the gear so that you can uncheck find reflectors and then check find black and white wedge targets. Now, please, if you don't see this, because you must be on the latest version, which is 2.19.1, if you don't see all these options. Yeah? So then you want to configure your target. Of course, the next option is to select the scan positions that has a target. So if you have a 100 scan position, and if 20 of them has it, and you forget to know which 20, you can certainly select them all. Of course, it may just take a little bit more time, but it will find it. And then you hit next, and then this is where it asks you to select what type of targets you're using. Of course, you want to select the target that you used last. And then you just hit OK, and then you hit generate type points, and then that's what you get, a list of type points. Now, interesting, here you can see under number of points. Now, on most of the targets, I only hit it one time, meaning that I only put the scanner next to it one time, so it has So it sees the target, but on one of the targets, I wanted to detect the same target from two positions. Yeah, it's because with our cylindrical targets, when you put it on a bipod with a monopole and put it over a known survey control, I highly recommend to scan it 2 times. The reason why is because when we scan it 2 times in the first step of a MSA2, you can see here in the deltas, yeah, the delta, it can then detect and let you know the differences between both setups. So if you scan at one position, you hit that target, and if you move to the next position, for some reason a gust of wind blew, and then that target moved, well, that's what you'll see, the deltas, that'll change. So it's advantageous to scan a cylindrical target at least 2 times, especially when you're doing road projects, environments where you're outdoor, and then that rod has potential to move, right? That way we can detect the deltas between both the rod from both setups. In other words, we can detect if the rod's level or not if you scan it twice. And then once you have your control, you then just follow the step 2 is import your control. 3, I didn't want to go over this because I've already done this, and it would just take time. And then step 3, and then step 5, and then finish it off. Okay. Now the residual I got this is absolutely incredible. In fact, let me show you really quick. Sorry, I was right here. It's just a report. There we go. So if I scroll down, so this is our office, beautiful Winter Garden, Florida. If I scroll down, here's my positions, scan positions that hit a control, right? So we have some independent positions, but don't worry. If you know our workflow, you know our workflow does not require every position setup to see a server control. Just think of it as you're building. I have to give credit to my colleague that gave me this analogy. You're building a puzzle on a table. When you're done with that complex puzzle, you pick it up and then you resect it down to your server control, right? So, and our software allows us to put a weight to force, whether you want to emphasize the server control registration, or if your control haven't been leveled and it's just floating, like RTK, for example, you want to then put a higher weight on the planes, right? Otherwise, it might break your scan apart. So we have a different workflow for all that. But nevertheless, just to show you, those are our residuals right there. It's absolutely unparalleled to anything I've seen, especially, and I'm talking about within the RIEGL workflow and target types and usage. Yeah, these flat targets, I've never seen anything, the residuals like this ever. So quite impressed. You can see here we're in the millimeters the entire way. Very nice. Okay. And then the other option to detect targets is on the right-hand side. So if you didn't want to go through the MSA2, you can just simply right-click on the control, the scan position file, and then select Find Targets. And then you're going to get an option to define what type of targets you're using, right? What you saw earlier in MSA2, same exact thing. So yeah, so there's 2 ways to detect. One MSA2 with the registration workflow, or individually from each scan position 3D point cloud file. Okay, not the position, the file. Okay, moving on. So getting into the good stuff. So you can see here, we have our project. I brought in all the data. You can see that not every position has control. So the back of our office, building, facility, you can see here I started at number 1, top, and then to the right, 2 in the grass, 3 over here by the car, 4 to the right, control, 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 and control. Yeah, so that's the results and the value that you get from it. And to show the vectors, right? So the vector is the earlier in my PowerPoint when I had a 3D image screenshot of a scan position that shot a vector to the control, and that's what it is. So some people don't know how to turn it on, but here's how you turn it on. You just bring the data into your 3D view, open up the object inspector, highlight all the scan positions, go down to your properties, check visible, and then also enable TPL socks, okay? And that should show you a vector. So before we end, I want to go ahead and then now show, and then, so sorry, oh my gosh, I apologize. No, not done, almost done. So that's how you detect targets, okay? And that's how you use targets. Now, I want to iterate that only the latest version of RISE Scan Pro 2.19, 2.19.1 contain this module, this software detecting black and white targets. Also, it's license-based, okay? So latest version, license-based. So please come check your sales rep and get more information on the purchase. All right. So before we end it, I want to show you the last thing, which is bringing the kinematic into terrestrial, right? So you can already see here, I also scanned this area in mobile mode, okay? And before I show you mobile mode, the workflow on how to bring in a kinematic data set with a terrestrial data set, I want to show you a couple of projects that I've done this year already using the VZ600i, but also the 400i too as well. So here is the 600i. No, sorry. So this is a radar mode. Before I zoom in onto some details, I want to show you the type of platform that it was mounted on. Sorry, I gotta have the picture. Well, without showing you the vehicle, I want to show you the mount, right? So this is the mount that was used, placed on top of a vehicle with 2 parallel racks. Okay, nothing special. It's just that it's great because it has a quick release, 3 screw, and it also has wire isolators for all-terrain conditions. Yeah. So here is, we made 2 passes around this facility. This is a hotel. This is, first of all, the first pass is in radar mode. So I'm going to zoom in just to show you. Radar mode is when the scanner continuously scan. Now, if you, our manual, our updated manuals does have instruction on how to use, and then in fact, my next webinar will cover on how to use the scanner in kinematic mode. Yeah, but I've had so much questions about, hey, how do I bring in kinematic data with terrestrial data and register? You know, so I found a quick way. So here you can see radar mode. You can see the points kind of sparse, right? But the the scanner also has something called a fixed line mode, meaning that instead of spinning, the scanner will rotate to a desired position, which is the horizontal, which is the phi angle. And then from that angle, the mirror just spins, and as you're driving, it creates a 3D model. All right, here we go. This is the line mode. Let me show you the difference. Point density, okay? You can see this is the line mode. You see how nice and clean it is. You can see your curves. Just for quick reference to show you some compelling information on how clean this is, the cross section will only justify that question. There we go. So that's a curve. I'm going to go ahead and throw on my grid. Make the points bigger. And you can see zeros right here, less than 1 centimeter, 0.1. Very, very clean. Very, very nice. Okay. Now this is from the 600i. All right. Let me zoom out a little bit. Now you can see we have some missing data from the project because that's only the line mode. Because we were only interested in the building. Now, if we wanted the whole facility, we just turn on the radar mode. Now, mind you, I only drove inside lane, yeah, and not through the parking lot. Now, if you were doing an alta survey, we're going to have this survey done in 5 minutes field time, period. That's it, right? So very, very nice tool for a quick, large alta survey. You can see quite nice. Okay, again, this is data from the 600i. Now, those that have the 400i can still make use of our mobile feature, right? So please contact your local rep for more information on how to enable the mobile feature and what is necessary to make use of the kinematic feature. And then those that have the 400i, this is the same data, sorry, 400i collected with the 400i on a moving vehicle as well. Now, of course, both project, this is the this is the radar mode. You can see the lines are very sparse, and there's not a system, there's not a uniform pattern. Okay, but then when I turn in the line mode, now our interest is just the building. You can see now we have a very, very nice uniform, high density, perfectly registered point cloud. And to show you how easy this is for processing, you bring the data in as you normally would with any terrestrial data set. The first thing you do, look at the data to make sure it's fair. And then the next thing you do, as far as processing it, Object Inspector, Trajectory, right-click on the original trajectory, refine trajectory, put about 20,000 values in there, select your assume scan condition or project. Everything outdoor urban. If you're in a forest, then the other option. Yeah. Put the value 20,000 and hit refine, and then bring the data back in. It'll be very, very nice. That 20,000, that value means how many planes you're controlling, how many planes you're gonna let it find, right? And the reason why it has to find the plane is because in my previous webinar that I showed last year is because we use the laser data to really refine the trajectory, right? What I mean by that is because we know our strength and we know our weaknesses. Yeah, our weakness is our IMU and our real-time GPS information, which is RTK versus PPK. And then what's our strength? Our laser data, right? So we use our laser data to detect, automatically extract planes, and then to refine the trajectory. And it's also used for multiple passes too as well. So you can see here, I made 2 passes, one in radar mode and one in fixed line mode. Now, of course, these 2 passes is going to be very off if I didn't have a way to refine it, right? Because the first go around, every second passes by, different timestamp on every single laser point. Yeah. But yeah, so this is a data set of the entire facility. Of course, area of interest that are black, sorry, the area that are black is because we did not have a line of sight, but nevertheless, very nice and very quick. And then let me just do a quick cross section of this to show you the radar mode and also the line mode. That, let's see, I'm trying to find where it's dense. Yeah, this is trying to, I'll do it all the way across here too as well, so we're not just biases in one little area. Okay, single color mode. I'll just make the points bigger. You can see here the pitch of the roof, orange versus blue. Each color represents its own independent passes and position. You can see the roof is good. Let's look at the other side of the building. Here's a curb. Yeah, very, very nice. Right? If I turn off the radar, oops, that's your line with the radar. Okay. Now, getting to the last part of our webinar is now, let's say I want to bring kinematic data in here. So I already have I have 2 separate projects. You want to first collect the data separately, static mode, right? And then create a new project, mount it on your vehicle, and then drive it, okay? Want to go ahead and close down this view. And the first thing you want to do, just pretend these are not here. You want to right click on your scans and then say new scan position. Yeah. And then you just want to rename it to whatever you want. Record 003. Okay. Since I know the project for this building has 2 records, I want to go ahead and make 2 records of it. Okay. And now you can bring in the data using the RIEGL native format, which is .rdbx. Yeah. So in your right click on the scan position and then say import. Then it's gonna find your project. So here I already have one set up. So here's the kinematic one. You want to look in the .rdb file. People want to look at the scans. Don't go there. .rdb, but you first want to change this to .rdb. Don't worry, this is all recorded. You go to, there you go. Scans, you want to go ahead and look at your scans. Laser data. There you go. RDBX. Open. It's going to ask you for this information. Just go ahead and click yes. It brings it in quite fast. Okay, as it's doing that, now just for time's sake, I've already done it I've already created both scan positions, okay? That, all right. So now I can view the data. So once it comes in, and this data using the RDBX has all the same attributes. So you don't have to export, you don't have to import. Sorry, you don't have to export, you have to import, obviously, right? So yeah, so here is the data. Now, unfortunately, I did not have one in fixed line mode. These are both radar mode. When I found out I made a mistake and didn't put it in line mode, it's not a mistake. So this is line mode. This is, sorry, radar mode. Okay. And then the second one is also in radar mode. Now, again, you want to process both data set differently in RISCAN Pro. Okay. Those of you that don't know, the kinematic data that's collected from the 600i to the 400i is also processed in RISCAN Pro. All right. So make that clear. And then you want to drag in the second kinematic file. I'll make this one just a single color, just money. Yeah, sure, money. Yeah. You can see, right? So it overlays both. Yep. Okay. But where does that line up with our threshold data, right? So don't forget, our threshold data is on survey control, so our threshold data is fixed. Bring these guys in. Well, we want to hold it at least. I'll make that just different colors. All right. Now, let me do a cross section to see, again, the kinematic data does not have control because right now survey control is not currently introduced. So we have to control the kinematic data somehow, and this is one way on how to do a cross section between the entire project. I'll put it sideways. You can see there's an offset between so the top right here, that's our static data, and our kinematic data is certainly below that. Yeah. Okay. Let's see if we can tighten that up. And this is my way of doing it. You want to first go to registration. Those are familiar with, we're going to go ahead and create plain patches. Okay. Select point clouds you want to create the plain patches for. Sorry. Kinematic. I didn't have kinematic stick. Yeah, so you take those two kinematic ones. Nope. Now right click, extract plain patches. There you go. So that's for the kinematic, right? I just simply use a default on this one, and then I hit OK. Once that was done, I went and looked at the plain patches, which will be stored in here, and this is what it looks like. Let's see. Yeah, so these are all the plain patches that it found, which is a lot. This is good. This is great. This is what we want, right? And then if we look at the other, perfect. A lot of overlap between the two, but also more importantly, it overlaps with the static scan. That's what you want. Yeah, you see how the white is static. It has a lot of overlap. Perfect. All right. Now we can begin our adjustment. So you just know now, most decision adjustment, not the two. I suspect this workflow to do all this will be introduced in here. But for now, those that want to make use of it, that have all this equipment, follow this workflow, right? So in principle, you have all your positions here, right? So 1 through 7 is our static scan, which is tied to our control. So you want to go ahead and select those all, and you want to lock the position and orientation on those, okay? And then with the static, sorry, with the mobile 1 and 2, you want to go ahead and let it move to the static. Ignore tie points, ignore tie objects. We want to use our plane patches, of course. And then ignore measure scan position, right? So people will tend to get the GPS versus control kind of mixed up. When your data is registered down to server control, your GPS information is suppressed, right? So regardless if you had good GPS or bad GPS, if you're using control, your data is suppressed. The only time that GPS is very important for an application is alpha survey, in my opinion. Other surveys too as well that I'm not sure about. I'm not a surveyor. But if you were doing an alpha survey, you don't even need control. You can just use RTK, and that's typically good enough for deliverable values, deliverable quality, geospatial quality for alpha surveys. RTK GPS is good enough. Okay, so now I can begin the adjustment. So I'll just keep it on low search radius. I'll let it move just 5 centimeters. 2, I'm going to go ahead and run this 2 times, and it should be good. So something like that. Calculate. You can see I want the bottom to move to the top. Okay, so it's moving. Perfect. Now I just want to reduce this 6 mil, 3 mil. Oops, please square fitting. And then okay, let's check it out. So what it's telling me is that it's got a good evenly distributed of matching planes, right? So you want the histogram to be right in the middle of a bell-shaped curve. You don't want it to skew to the left or skew to the right, is because what that means is that all your planes is in one certain quadrant, right? So if you look at this cube right here, is 3D sphere, sorry, not a cube, sphere. And you have planes in all 4 quadrants of a 3D sphere. That's what you want, right? So you want a perfectly bell-shaped curve with small outliers. And I'll run this one more time, right? So the outliers are kind of big still. But before we do that, let's go ahead and look at the data. Yeah. So let me just bring all my data back. I'm going to do another cross section. And we're almost done. Here's my, I wanted to get this little area. Okay, so let me run it one more time to see if I get better results. So if we just go 1, let's reduce this, if we tighten it up. No. Okay. Yeah, so this is how you do it. You know, you can continue to move on or you continue to stop, but yeah, that's it. So now if you look at the project, I'm gonna go ahead and scale it back a little bit. Now it becomes a very comprehensive point cloud, right? So we have points on every single area that our scanner passed by. So if you go here, we can start. Right. So this is just our kinematic data. Very uniform. You can remove all those too as well. But then I can just turn on, like for example, I don't have data here, right? Scan position 1. I just go find scan position 1. Turn it on. Boom. Look at that, right? I don't have much data here. I can just turn on scan position 2. Boom. And so on. Okay, and then this data is just as good as any the rest of the data in the project. You can export it, combine it, filter it out, do whatever you want to do with it. The last thing I like to do is just make this thing. Go ahead. Sorry, I've got to close this. Right click here and make it registered. Also make it registered. And you can name it any way you want, right? So now this SOP matrix has values. It has a populated SOP matrix. Otherwise, at the beginning, when I first imported the kinematic data, it's this binary ones and zeros, right? So there you go. That's how you combine a static with a kinematic using a special laser scanner. Yep. All right. So that brings us to the end of our webinar. So if you're available on the 23rd of May, please join us for our an amazing expedition and a closer look through the eye of RIEGL terrestrial laser scanners, RIEGL technology, because it was flown with other unmanned sensors too as well from RIEGL. But yeah, there will be a webinar, pretty interesting. The data is incredible. We introduced long range, short range, scan across the bay from the rock. The 600i was used indoors to scan all the cells and some of the famous cells. So yeah, you're not going to want to miss this. It's going to be very, very interesting. So, okay, I will close on that note. Thank you for your attention. And then, Andrea, please, I always mess this part up on answering questions because the ability for me to see the question is so small. So let me go ahead and answer some questions, okay? So if you have questions, go ahead and answer. No, sorry, ask. Questions. Okay, I see one. I just wish I knew how to make this bigger. Okay. You know what, let me put this. Okay, so I got a question or a comment. Let me read it. Okay. Yeah, no problem. If you want me to share this data set, I may not be able to share this particular one, but I can share one that I've done out in this road, only because I don't know. I don't make this. I'll share. I want to share whatever. I don't really care. But I just gotta. Yeah, no problem. I'll share some information with you, and I will go ahead and get your. No problem. All right. Great. Any other additional questions? Thank you for that. Okay. Let's see. One of my. Okay. Well, I assume I don't see any more questions. Should I wait? Thank you for the kind words, everyone. Again, this is just to get you going because I've had so many questions about how to make use of black and white tar. Because I did introduce this last year, but I didn't get a chance to use it until this year, and I was been having so much questions, and also questions about how do I bring in terrestrial data with kinematic data, and I think there's going to be a streamlined workflow in the near future. I know our developers are working hard at streamlining all this. When I say streamline, meaning that less clicks, right? So the less clicks, the better. Although what I did was not anything, you know, out of the ordinary. We've seen all this before if you're a RIEGL user, especially in the past when you had to make use of a lot of targets, right? And so you've done this before. I'm just connecting the dots for you. But the black and white target is pretty cool. In fact, if I were to check this out, right? So that's our black and white target right there. If I were to go to a position, for example, I think this position number 5, I just drag in the TPL socks. TPL socks, nope. 4, nope. There we go. Yeah, right here. Perfect. Yeah, so this is, this is pretty cool. Yeah, so this is our 3D data. And then the model that we created looks like that. Right in the middle. Type 1. And our scanner, let me see. Boom, look at that, vectors right there. Okay. Oh, I got some more questions. All right, hang on. I wish I could make this thing bigger. Okay, great run is down in indoor. Indoor kinematic. I don't. I cannot promise any results, but you know, RIEGL is always pushing forward, expanding the boundary of our capabilities, and also making use of our technology to the fullest. So if I were to say no, that would be a lie. If I were to say yes, that would also be a lie. But I'm very, very optimistic that this will go indoor. I don't know when, I don't know how. Well, I might have an idea, but I don't know when, but you know, we could. Okay, when will the webinars be available? Usually it takes about a week or two for it to be available for public to access, okay? But please join our LinkedIn, our social media platforms, because you get updates to all this. All right, let's see. Okay, those that stuck around, thank you so much. And those who participated, thank you so much. Have a great day. And if you have more questions, I'm here for you. Cheers.